Hello everyone. Today our presentation will tackle about the searching algorithm, specifically the jump search algorithm. The objectives of this presentation is to discuss what is the jump search algorithm, the steps on how the algorithm is done, the example of successful and unsuccessful search, and last but not least is to discuss the algorithm's advantages and disadvantages. So let's begin. So let's tackle jump search algorithm. Jump search algorithm is a relatively new algorithm for searching an element in a sorted array. The idea of this algorithm is to search fewer numbers of elements compared to the linear search, skipping some fixed number of array of elements or jumping ahead by a fixed number of steps in every iteration. It lessens the number of comparison by jumping the indices of length m, thus getting a better time complexity compared to linear search. So how does the algorithm works? First is to find the jump block size m. We find that with the formula of the square root of n. N is the number of elements, so we take the square root of it. Next, if a array of I is equal to the target, then return I. I is the index to compare. So basically, this line means that if the index value is equal to the element that you are looking for, then just return the index. Next is if a of I is less than the target, then I will be equals to m and increment of m plus square root of n. So this just means that if the index is less than the target, then we will increment it by m plus square root of n. Then repeat it till the m is less than n minus 1. Next, if a of I is greater than the target, then perform the linear search from a I index minus the square root of n to the index of I. We will show you an example and further elaborate it so that you can understand it better.
So, let's have an example of unsuccessful search. So, consider the following inputs. The array 0, 1, 1, 2, 3, 5, 8, 13, 21, 55, 77, 89, 101, 201, 256, and 780. So, we're looking here for number 77. So, step 1, our formula is m is equals to square root of n. So, our n will be 16 because of the array, which is 16. So, doing that, square root of 16 is equals to 4. So, 4 will be our block size. So, first, we will compare the item to array 0. So, since the item is greater than the array 0, we will skip to the next block, which is on array 3. So, we will do that again until the array is greater than the item. So, moving on with the next block, array 3, we will compare again. So, the item is greater than the array 3. So, we will move to the next block, which is on array 6. And doing that again, the item is greater than the array 6. So, let's move to the next block, which is on array 9. So, 77 is still greater than 55, so we will still move to the next block. And moving on to the array 12, so in this case the array is greater than the item, so it will scan the block element by element. So it will first scan the array 9, but it is not equal to the item, so we will move to the next element. So array 10, so 77 it's equals to the item. So index 10 is printed as the valid location and the algorithm will terminate. So now, let's have an example of an unsuccessful search. So let's consider an array of sorted integers 1, 4, 7, 9, 12, 15, 18, 22, 25, and 28. Now, let's say we want to search for the number 10 in this array using the jump search algorithm. So, the algorithm will start by jumping ahead a fixed of number. So, let's say 3 steps ahead. So, initially, the algorithm will compare the element at index 0, which is 1. So, since 1 is less than 10, so it will jump 3 steps ahead. So, the algorithm will now compare the element at index 3, which is 9. But since 9 is less than 10, so it will jump another 3 steps ahead. So, the algorithm will now compare the element at index 6, which is 18. So, since 18 is greater than 10, so it will perform a linear search between indices 3 and 6. The algorithm will traverse the element one by one between indices 3 and 6, which is 9, 12, and 15. But none of these elements match the target element 10. So the algorithm will reach the end of the search range without finding the target element. So, in this scenario, the jump search algorithm is unsuccessful in finding the element 10 in the sorted array. So, the algorithm exhausts the search range without locating the target element, indicating that it is not present in the array.
These are the advantages of jump search algorithm. First is the performs better than linear search. Jump search has an O square root of n time complexity, where n is the array size in elements. This is better than linear search, which requires an O of n amount of time. Jump search is faster and more efficient since it requires fewer comparisons. Second is simplicity. Implementing jump search is rather easy. There are no complex computations or recursive stages like in binary search required. The last one is works on sorted arrays. The array must be arranged in ascending order in order to use jump search. This approach may be used to quickly discover elements after sorting the array. And these are the disadvantages of jump search algorithm. The first disadvantages of jump search algorithm is requires a sorted array. Jump search is restricted to being used with sorted arrays. If the array is not sorted, sorting the array in a separate step is necessary, which might add to the total time complexity. The second one is limited efficiency compared to binary search. Jump search is less effective than binary search, but it is more effective than linear search. Compared to jump search, which has a time complexity of O square root of n, binary search has a time complexity of O logarithmic of n. The last one is requires random access. Jump search makes use of random access to array items. It has to be able to access items by index, which is doable in arrays but might not be in other data structures where direct access is either not enabled or expensive.